Hello students, let's start another chapter. Science, Lights and Shadow, class 5 from the book Headlights. Okay, let's start. So, here we are studying about luminous and non-luminous objects. This is our first topic. Objects that produce and emit their own light are called luminous objects. The light emitted by luminous objects can be seen from a distance and contributes to their visibility. For example, we have stars, light bulbs, fire and lightning. See here, and then we have non-luminous objects. So in this paragraph, we are studying about luminous and non-luminous. Now how the question comes. Generally, they give a differentiate, write 2 points. Luminous and non-luminous objects. Luminous emit their own light. Non-luminous do not produce their own light. Example, light bulbs, fire, lightning. And for non-luminous, we have moon, planets, trees, buildings. See, it's given here. Light reflected from an external source are called non-luminous objects. These objects become visible only when illuminated by a nearby light source. Illuminated means when the light falls on it, they become bright, and that is why we are able to see. See, this is a normal mechanism that how are we able to see an object. We had done the chapter of sense organs, if you remember. Now, how an image is formed in the eye, we discussed about it. Now, suppose you have a pen, right? Now, this is a pen. Now, I'm able to see this pen. Why? When the light is falling on this pen, from this pen, the light is getting reflected back into my eyes, making an image on the retina by which the sensory cells in the retina get stimulated, send the signal. Optic nerve, see, you have to always correlate. Otherwise, you are not able to study science. So whenever you have done chapter of sense organs relating to eye, so you should know, try to remember when we are talking about light, how we are able to see the objects. Now see, there are certain objects which have light of their own. Here we are saying these are the artificial ones. Bulb, fire. Now this is a natural source, you can say lightning, or say sun. Most important, stars. They can be asked man-made and natural and artificial. See, there are many ways of the questions being asked from this. Then we have moon. See, moon is only rocks, right? So remember, moon does not have light on its own, because majority, see, what is the general we feel that moon is having lights. That is why we are able to see in the night also, when there is a beautiful full moon and there is light everywhere, but actually it is the light from the sun falling on the moon, getting reflected back, and so the moon appears to have its light, but actually moon does not have its light. So remember the example of this. Our planet Earth or any other planet, we see any example from the classroom you can give, desk, chair, yourself, your teacher, right? They are all non-luminous objects. Okay, so we have transparent, translucent and opaque. Transparent objects allow light to pass completely through them. You can see through the window of your home or of your class. Clean, this is a transparent glass. So there are other glasses also which are not considered transparent. See, especially in the bathrooms where we want only some light but we do not want the visibility. Those are called frosted glass, right? Remember the difference between the two. So what are transparent? Here they allow the light to completely pass through them. So we are able to see the object, any object which is on the opposite side. Transparent objects include clear glass, clean water and clean air. So glass, water, air, but clean. But clear glass, not clean glass. It was clear glass, clean water and clean air. Translucent are those which allow only a part of light, some light. So they do not allow a clear view of the objects, like frosted glass, trace paper, muslin cloth, or even if take a paper and put butter or oil, so it becomes the butter paper. So butter paper is not given here, just remember it. And if I say spectacles, it will come under transparent. because it completely allows the light to pass through. Acha, what about mirror? Mirror is what? You see yourself, combing your hair, doing makeup right in front of your mirror. So what is that? See, these sometimes, these type of examples come as 1 mark questions, true, false, or none of the above, like these type. And mirror is a very favorite of many teachers. Why mirror? Mirror will be, mirror is an opaque. Why? Because in mirror, one side is polished. That is why you are able to see your image. If the light goes throughout and throughout, can you see your image in the glass window? No, no. So mirror, one side is polished, the side which you cannot see. That is the funda of the mirror. It's light cannot pass through the mirror. Okay. So you remember this, these type of, there are many other examples also, but sometimes, these are very common ones. If you see, if you are not able to understand, say there is an example, you are just not able to understand, so you think that you are standing behind that object and one person is standing in front, so will he be able to see you? If yes, then it is transparent. If just slight, then it is translucent. And if no, then the answer is opaque. That's it. Okay. This is a very basic way of understanding that whether it will be there or not. Like, so that is the way. Okay. Opaque do not allow any light to pass through them. Opaque materials block the view of objects on the other side. Like metal, cardboard, wood, okay, they all block. So now we come to what? This page, right? Jellyfish have transparent body parts. See, this is an example given of natural adaptation, like how animals protect themselves. Jellyfish makes is transparent, so it is an advantage when the fish is hunting, so it cannot be seen, right? Light will pass through it. So unless the part reflects the light back, no one can see anything, right? Okay, there is something called a greenhouse effect. A small paragraph has been given. So what actually happens about greenhouse? See, what happens is that if you have glass, a small, say a room which has only glasses. Now the sunlight is entering inside because it is transparent. So the light goes inside. Now the inner part remains heated. So this mechanism was used for growing plants, especially in areas where it was cold, so that it traps the warmth of the sunlight. Now what happens in the Earth's atmosphere? This is a greenhouse. See, greenhouse is a place where which is used for growing plants. So what can you use for it? You want the light to pass through it, so only transparent materials, sometimes transparent plastic or transparent glass. This is the material which is required. Here there are 3 options given, out of which you will choose clear glass. And the mechanism is the greenhouse effect. Now what is that mechanism? Like in normally what happens is sunlight is coming. Now, between the Earth's surface, means on the ground, what is present in between? Atmosphere, clouds, dust particles, water vapor, so many things are present. So, when the light is entering the Earth, the heat and this sunlight gets absorbed by all these things. Right? So, so this warmth is retained. That is the reason even during night, otherwise see, if the sun goes off, since the earth is rotating, so there is a part when we are away from the sun, so it should become extremely cold, but still we have this warmth due to which life is possible on earth. And the main reason for it is this greenhouse effect and the gases, the responsible for absorbing this warmth. So what happens is, now you will say, why when it reaches the surface of the earth should get reflected back? Very, very less it gets reflected back, because majority of it remains absorbed. And even if it is reflected back, again it is the gases, the water vapor, everything present in the atmosphere, which again absorbs it and then it emits it, leading to this warmth. So now these days when the pollution is huge, so the gases are also, the amount of carbon dioxide has increased, which increases the warmness. That is why this has led to global warming, because it is absorbing the light, more warmth. So there is this, see, in this the greenhouse effect should not come, because in your syllabus, in this book, it is given only about the mechanism why we are using glass and not wood for making the house, because glass allows light to pass through it and it enters inside it, and this warmth is required for the growth of the plants. Okay. See, in this we have done everything, I think. Let's do it again. Classify the following as transparent, translucent, and opaque. Anything. See, frosted glass, muslin cloth, and trace paper, which was given in the previous page. These are all translucent. Opaque, you know. Bag, cardboard. What else? Trace paper is translucent. Metal is opaque. What else? Pure water is transparent. Reading glasses. See, I was talking about the spectacles. This is a very good favorite question also. Again, see, plastic toy can be considered, and it depends if you are using which type of plastic it is. If you use a very cheap quality plastic, then it will be translucent. Otherwise, it comes under opaque only. Right, because see, you get those very cheap quality plastic, yeah, glasses, so, but otherwise plastic toy will come under opaque. What else? Okay, so what else? Shadows. See, this is a very important topic. What we had done before, luminous, non-luminous objects, I said let's do the questions also. I said what can come, differentiation between the luminous, non-luminous. Examples: transparent and translucent. Translucent is like 1 mark question, which is a bit confusing of some of the examples. Otherwise, if these examples we have done, other than this, just remember that these are all especially spectacles and mirror. Okay, now we come to shadows. Now, what is a shadow? Shadows are formed when an object comes between a source of light and another source. Between a source of light and another surface, sorry. The object blocks some or all of the light rays and creates an area of darkness on the surface opposite the light source. The absence of light in these areas results in shadow. See, what happens is, if you see the diagram, you have a light source and you have a surface here which is called the screen. Now light is coming. Light always travels in straight path. Now if I put anything in, obstruct the source of light, so in this area the light is not coming through it, because this is an opaque object, right? So it is blocking the path, due to which in this area the light is not able to reach, and that is why a dark area is created, and this dark thing is called shadow, right? Here the rest of the area remains illuminated, because see, the light is coming from everywhere, only this part is getting obstructed, and here we are able to get the shadow. So the shadow, so there are 3 things involved in this process. One is the source of light, object, and screen. So these are the 3 things which are required for formation of shadow. The formation of shadows requires a source of light such as sun, lamp, or any other light emitting object. What is an object? An object is required to block the light rays. Now, which objects again block the light rays? We said opaque and partially the translucent. So, if the light is being blocked partially or less by a translucent, so definitely the shadow will be lighter. Right? The interaction with the light determines the shape and characteristics of the shadow formed. Yes, definitely. I'll talk about this later. Screen is the surface on which a shadow is formed. It's just opposite the light source. See, the this opposite word is also very important, can come as one mark question, that the shadow is formed where? It is always opposite of the light source. So this word opposite. It receives the light rays, and when an object comes between the source of the light and the screen, a shadow is formed on the screen, right? Now we come to the next thing. Okay. Now see, it is asking, if you stand during the day, the shadow, you can see your shadow in the morning, evening and afternoon. But the shadow, the size is different. Yes, in the morning and evening they are always long, but in the afternoon it is smaller. Because in the morning and evening, see, the sun is rising and then setting. So the sun rays are inclined. But when the sun is vertically overhead during the noon, it is coming directly over the head, and that is why the reason the shadow is small. See, there is a lot of explanation for it. If you really want to know, you have to see, those a very beautiful way of showing in Google. You will find the videos of shadow and eclipse. You must watch, because you will come to know. Otherwise, what question can come here in the syllabus? Nothing has been given about the explanation. Only they are asking why the size of my shadow is different during different times of the day. This is due to the sun rays being inclined in the morning and evening, shadow being longer. During the afternoon, the sun rays are vertically overhead, and so the shadows are small. So it is, the inclination part and the vertical head, the rays coming is the reason for it. Now see, there is another way of asking this question. Suppose, let me draw it. Suppose I say, this is a sun, right? And the sun was here. It was coming like this. Now it is here. And Rahul is standing here. These are the points P, Q and R. Now, as he is walking from P to R, will the shadow increase or will the shadow decrease? See, the framing of question can be in any way. So you know that the shadows are always longer in the morning. They can write here morning, and they can write here afternoon. So as I said, morning the shadow is always larger, and here the shadow will be small. At one point, even there is a day and a point when you cannot have any shadow. It's no zero shadow day. You must zero shadow point. You must see in Google when it happens. So it's not in your for class 5. So this question can be asked. So as he's moving from P to Q, the shadow goes on becoming smaller. So this is one way of asking a question. Okay. Look around and name 5 objects that can form shadows. You name any opaque objects in your class, and you, from your pencil box only. There are 5 things in your pencil box, including you can name yourself and the bench and the desk and blackboard and everything. Okay. Properties of shadow. The shadow depends on the size and shape of the object and the distance between the object and the screen. This is very important. See, always remember, like we had this figure. Now this is the object. I can decrease the object. Make the object closer to the source of light. See, what happens is, if I make it closer, the shadow will be bigger. Why? This is called inversely proportional. And if I make the object move away, the shadow will become smaller. You have to just remember, when it comes closer, what happens is more light is getting blocked, right? So that is why the shadow appears big. So this question can be asked in any ways. Relationship between the source of light and the object. What happens if it is brought nearer? The answer is shadow becomes more. If it is becoming far off, the shadow becomes smaller. And again, if the screen, it's if you make the screen far off, it's opposite. Like it will become big. So it will depend on the size, shape, and the distance between the object and the screen, and also between the object and the source of light. So question related to this is also a very good question. See, properties of shadow. If I ask you, write two properties of shadow, say. So what are you going to write? You can say, yes, it is always black. Shadows are never colored. Never. So it is always black. Number two, shadows are formed on the opposite side of the light source. This is also a property. It depends on the size and shape of the object. Yes. It depends on the distance of the object from the light source. Distance of the object from the screen. Yes. So, these are all the properties. You can write any two. So you can write, out of this you can write a very good one would be, I think it is always black, formed always on the opposite side of the light, depends on the size and the shape of the object. See, in this what happens is, if the object is round, then the shadow will always be round, right? So shape of the shadow will definitely be according to what is the shape of the object. Now if you put a fork and you expect a round shadow, it's not possible, right? And the size, as I said, will depend upon the distance. So filling the blank, see, I'm doing the question side by side. There is no extra question which needs to be done, right? Filling the blanks, it creates a shadow. See, there are three basic things required for the formation of shadow, which we have done. That is the source of light, the object, and the screen, right? Okay. What else? Properties of a shadow depend on several factors such as size of the object, shape of the object. I would say size and the position of the object. That is a more important point, because the shape will definitely be of the same of that of the object. Screen is the surface on which a shadow is formed. So, they can directly be asked what is a shadow, or a dark object or a dark thing seen on the screen when an object is placed in front of the light is called dash, shadow. Okay. Now we come to eclipse. See, eclipse looks very beautiful. You must watch a YouTube video about it, because it's a three-dimensional phenomena, right? So it's very difficult to explain on a pen and paper, because the alignment, see, Earth is rotating, also moving around the sun. Moon is also rotating around the Earth. So there is a point when all the three come together in one alignment, right? Which comes very less. So only then you are able to see an eclipse. So what actually eclipse is, when, see, it's based on this concept of shadow, right? Now the sun is the main source of light, Here we are talking about the heavenly bodies. So a shadow, the concept of shadow for the heavenly bodies, it results in eclipse, right? Earth and moon do not have their own light, we had said. So they block the sunlight. At times, sun, earth and moon are in a straight line. So see, you cannot just imagine in this 2D diagram that yes, they are in the straight line. You have to actually see this to understand what happens. Otherwise, if the moon is rotating every 29.5 days on an average, it is rotating, it should come here, and every time we should get this eclipse. But we are not getting it, because the inclination of the earth orbit, moon's orbit. So the orbits are inclined. So that is why I told you should always see a video to actually understand why it is not happening every month. So where were we? Yeah, this causes a shadow formation which blocks the view of the sun or the moon for some time. So when it is asked what is an eclipse, you will write from here, which is given in your book. If your teacher has told another definition, a smaller one, you can write that. Otherwise, you start with here. Earth and the moon do not have their own light, and they block sunlight for each other. At times they come in a straight line, which leads to formation of shadow. This is called this causes a shadow formation which blocks the view of the sun or the moon. This is called eclipse. So there are two types of eclipse. So we come to the solar eclipse first. Now see, this diagram is a very good diagram, in the sense it comes generally in the exam. Either the diagram can be given, they can ask questions, or you are told directly what is solar eclipse, explain in with the help of a diagram. So both ways. And another way of asking the question is, they will give this question and they will mark this as X, Y, and Z. And one thing is wrong, and they will ask, if this is a solar eclipse, then which positions will you change, of which X, Y, or Z? Understood? So this is a normal solar eclipse, but suppose instead of here, if I give this picture, the lower one, and I say, I want to show a solar eclipse, so you will exchange the positions. Okay, so during a solar eclipse, the moon comes between the sun and the earth. The moon blocks the sunlight and casts a shadow on the earth. In the part of the earth where the shadow is cast, the sun cannot be seen. See, now the moon is coming here. Yahan se the light is coming. But the light, because it is being obstructed, it will not come here. See, the sun is huge. The moon is very small. So the whole earth will never be covered. So only a part, see, this a pinpoint area has been covered here, which is called, at this, a person standing here will not be able to see the sun. So for him, it will be a total solar eclipse. Right. Now, see, even in eclipse, there is a part which is jet, total black, which will be called umbra, and this portion, partial, will be called penumbra. It is not given in this book. Then it's fine. Just leave it. If in your school it is not being done, then you remember this is a very simple diagram, nothing to be explained. That this is a diagram of solar eclipse, and here this is total solar eclipse. But see, the concept is that if someone standing exactly here will not be able to see the sun, but somebody who is standing here in this part of the earth, definitely a portion will be visible. That is why it is called the partial solar eclipse. Okay, so if only a portion of sun is blocked, partial, otherwise total. And this happens during new moon. See, even this phases of moon has also been not given in the moon in this book. Otherwise, it was always better to first understand the phases of moon. Why are we able to see so many shapes? Actually, it's not the shapes, it is the amount, the portion of the moon which is lit, which reflects, and we are able to see that. Those are called the phases of the moon. So the moon traveling from here, rotating. So every time the part of the moon which we are able to see, those are called the phases of the moon. This is a one complete lunar cycle when it is rotating like this, but it's not given, so leave it. But it's always better to see those videos to understand the phases of the moon and then come to the portion of eclipse. Okay, now it is the lunar eclipse. It's the opposite. Now what happens? See, the light source will remain here. The earth comes between the sun and the moon. Now the earth is here. Now the moon was traveling. See, this is the orbit of the moon. So the moon is traveling, and there is one point when again three of them come in the same line. The alignment is the same. So whose shadow is coming? Now sunlight is being blocked by the earth. Here it was being blocked by the moon. So this shadow is falling on the moon. This results in the lunar eclipse. So what happens is that, you are watching the moon and suddenly you see that the moon you are not able to see, and after some time again the moon comes. It's the same like the sun, right? So again here also we have the partial and the total lunar eclipse. See here again the orbit alignment is different, which by this on paper you will not be able to understand. It's very important to visualize in a 3D form that how they come in a straight line and how they are aligned. And this is more frequent as compared to the solar eclipse. And the reason why the moon becomes red, see, we have this sunlight splitting into the parts. Only the red part of the light, it remains here. The other light, they get scattered, I think blocked. So only the red light remains, and that is why it appears red, or there are sometimes blood moon types of thing. So, but the basic difference between solar and lunar eclipse, if the question is like differentiate, moon coming in between, earth coming in between. Moon casting the shadow on the earth casting the shadow on the moon. This is less frequent, this is more frequent. We should not see, it is unsafe to see the sun during solar eclipse because there are harmful rays coming and it may lead to permanent damage to the eyes. We can see the moon during lunar eclipse. It's not harmful. Diagrams are very important. Oh, the chapter is complete. So what else are we doing here? See, this we have all done. Any special type of, if I say, question which is left? We cannot see non-luminous objects. Yes, we cannot see because they do not emit light of their own. Do not form shadows, faint shadows because of partial light. This occurs at the full moon phase. See why? Why? Because the alignment, they are aligned only when there is a full moon. When there is no full moon, they do not come also in a straight, in their alignment does not take place. So like in this, in solar eclipse, only during the new moon, this alignment will take place. Here only during full moon, the alignment will take place. That is the reason. Okay. This we have done. Okay. This we have done. Examples of transparent, how, when is a shadow formed, which type of objects form clear shadows, definitely opaque. To create a large shadow, how will you adjust the light source and why? I told you the smaller the distance, I mean, if the object is near the light source, we have a big shadow. Because more of the light gets obstructed. So that is why it creates a more sharp and big shadow. Okay. Question number 5. Lampshade for your study room. You want to design a cover around the bulb. See, there are two ways of answering this question, because see, lampshades are used in normal living rooms also. Let me answer first that. You have beautiful lampshades available for, those aesthetic beauty of the room. You want a pleasant light. In those cases, we use a translucent type of lampshade. Right, you want a partial light to come, it's glowing the room everywhere, it looks beautiful and not the too much of light. But if suppose you are studying and you want to keep a lampshade, just you want focus, suppose you want to focus here, you do not want the light should go in any other part of the room, then you have to use a opaque. Suppose if this is the light source, right, and if this is the lamp shade, I want to, if you see the table lamps, so here the question is a bit tricky in the sense that if it is a table lamp, I want a particular focused point to come here, and it should fall on the book and not anywhere say else. So I will cover the bulb from this side with an opaque one, right? So that the light does not go anywhere else and falls here. But if you want a light in the entire room and a pleasant sort of light with, less glare and everything, then I will use a translucent one. Otherwise, see, now here also you need one opening. Generally, what happens when if a bulb is there, you have an opening up, and in case of a table lamp, you have an opening down, and here is the bulb, right? So this question is depends on what actually you are wanting. Okay, then what is the next question? Uh, Several myths and superstitions, yeah, especially in India, we have all those myths. You should not throw away all the food. Do not eat during the eclipse. See, this is a scientific reason for the eclipse. So you cannot have those superstitions. Now everybody is educated, they know why it happens. So you need to educate the people. Two ways by which you can help people: you can educate them, show them how it actually happens and why it happens. So there is nothing to worry about it. Only during a solar eclipse you have to be careful, not look at the sun directly, and there are also ways of looking at it. Either you see the reflection through a cardboard making a hole, or you have special type of goggles for this type of, for watching the sun. So through education you can remove these type of superstitions. So this is not a science question, so leave it. I think the rest, what is actually important in this was the difference, the diagrams. Eclipse, eclipse is really important. This should be, especially the diagrams. It can come as a wrong diagram and told to you to correct it. I think that's it. Okay.